In this movie, I want to achieve two things. One, I want to show you how we can rotate an object around the X, Y, and Z axes from script, and then also to show you how we can rotate or spin an object over time around a particular axis. So let's get started at looking at that. So for example, what I'm going to do now is to create a new script file by moving down here to the project panel, right-clicking, choose Create, and I will call this C# script, and I will call this rotate2, like so, and double-click on that to open that inside MonoDevelop. So here we have MonoDevelop with our rotate2 script, and it's looking absolutely fine. So the first thing I want to do is to rotate the object to a particular rotation. We saw previously how when I select the capsule in the scene, I can rotate an object by manipulating the X, Y, and Z fields here, but here I want to do that now in script. So the way to do that is, first of all, we want to get access to the transform component. Now I'm going to do that as I did before by creating a new private field, and I'll call that transform and this transform. And once again, in the awake function, we're going to get access to that component by choosing this transform equals get component, and I will say transform like so, which will give us access to the transform component. Now when I do that and I choose this inside the update function, I choose this transform dot, and we can access the rotation of an object by using the field rotation. Now there are in fact two fields, rotation and local rotation. Local rotation refers to the rotation of an object relative to its parent, so that if its parent rotates, that rotation will be added on to the object. On the other hand, the rotation field refers to the absolute rotation of an object regardless of how its parent is rotated. So right now, all I want to do is just change the rotation of an object, so I will select that field. And to assign it a rotation of any arbitrary kind, I can choose equals, and we choose quaternion. So this is an internal class built into Unity that we can call upon to construct quaternions based on angles that we specify. So I can choose quaternion dot, and we get a range of different functions and properties that we can access. But if I want to set the X, Y, and Z rotation of an object, I should use the function here named Euler. Some people call this Euler or Euler. This simply requires a vector 3 structure that defines the amount of turn we should apply to each axis as measured in Euler angles, that is degrees. So one complete turn in degrees is 360. That represents a complete turn in a circle. 90 degrees is a quarter turn, and 180 degrees is a half turn. So I'm going to choose Euler. Now let's say I want to rotate this 0 degrees around X and 90 degrees around Y, and again I don't want to rotate it on the Z. So I'm going to specify this and press Ctrl S to save that code here. So this is the rotation around X, this is the rotation around Y, and this is the rotation around Z. So I'm going to save this code, and I'm going to drag and drop this code onto this capsule object. So drag and drop it onto the capsule here and release my mouse to apply the rotate2 script. Now you can see the capsule is facing this direction here in the viewport, and the rotation is set to 0, 0, 0. But if I press play on the toolbar, now the rotation is set to 90. So this explains how we can set the rotation of an object to any arbitrary measurement on the X, Y, and Z axis by using quaternion.Euler. This function is indeed very powerful. But of course, the next thing we want to have a look at is how can we turn this object over time. Now, to spin or rotate an object over time, we're going to see a very important property of quaternions generally. In fact, we're going to see quaternion multiplication, which gives us the ability to combine rotations together. So if you have a rotation A and you multiply it by rotation B, you are combining or adding the rotations together. It may seem strange to say that we are adding by multiplying, but in the world of quaternions, that is the way it works. So I want to spin this object around the y-axis by a particular rotation speed. So instead, what I'm going to do to this class to make an amendment is move up here to the top and introduce a new variable. So I'm going to choose public float, and I'm going to choose rot speed, and I will say 90 degrees per second. Then down here in the update function, I'm going to adjust the rotation. Now we can use quaternion angle axis to build a rotation around a particular axis. So I'm just going to comment out this line for the moment, and we can choose quaternion.angle axis. And what this function allows us to do is to specify an angle, for example 90 degrees, and an axis. So in this case, the axis represents a vector that defines the pole or the center around which rotation should occur. So for example, if I want to rotate around the y-axis, that is the up vector, then I would specify a vector 3 of 0, 1, 0. It would be 1 in the y component to indicate that that was the axis around which I should rotate. If I wanted to rotate around the x-axis, the value would be 1, 0, 0. In this case, I want to rotate by my speed around the up vector. So what I can do is choose rot speed, and you may remember that because we're inside the update function and we want to create a consistent speed over time, we have to multiply this by time.delta time. And where we put in the comma to create the second field, this is the axis around which we should rotate. This should be the up vector. I can specify this in two ways. One way is to choose new vector 3, like so, to define a completely new vector. And I could choose 0, 1, 0 to define the y-axis. I could do that, but instead, Unity provides us with a constant value we can use instead. I just have to type vector 3 dot up, and that constant is already represented for us. So this will build a quaternion that rotates by our speed around the up vector. Now, of course, this is going to provide us with a rotation in global space. What we want to do is continually add this on to our existing rotation. So I'm going to come down here to this rotation property and delete this right-hand side part. And I want to say, take our existing rotation, whatever that is, and add on this new rotation. So we want to combine it. And remember that quaternion addition happens through multiplication. We combine quaternions together through multiplication. So I want to say multiply equals, in order, that is, take the existing rotation and multiply onto it this new rotation, like so. And this now will allow us to spin the object continually over time. But, well, let's not take my word for it. Let's test that. So I'm going to go back to the Unity editor here and allow this code to compile. And when it does so, you can see that we have our new rotation speed specified here, so that we have the ability from the object inspector to change the speed. I'm going to press play on the toolbar, and now you can see that the object is rotating. That rotation continues to accumulate, and notice that as we loop around and go in a complete circle, Unity has the know-how to wrap the angles in the Y component, so that as we pass 360, it wraps around again to angle 0 in a complete circle. This is the power of quaternions to continually rotate an object over time. This is a very important ability.